Why we can say that it's a SOAP request? Why we can call it as a SOAP request here is because stub uses some predefined tags. Sub uses some predefined tags, set of predefined tags to prepare this XML document here. These predefined tags are called as a SOAP tags. We can say that SOAP tags here. So SOAP is a protocol which contains some set of predefined tags here. So stub uses some of the tags from this SOAP to prepare the SOAP request here. So now stub has prepared this SOAP request here. Now this SOAP request needs to send to this server location here. So who will move this SOAP request from client location to the server location here is HTTP protocol will move this SOAP request from client location to the server location here. So here the SOAP request contains name of the method, parameter values, parameter types also here. Now who will do this job here is who will move this SOAP request? No, HTTP protocol will move this SOAP request from client location to the server location here. So now the server will receive this request here. Now this request will hand over to the one component which is exist at the service side, that is called as a skeleton here. So now the server will hand over this SOAP request to this skeleton. Now skeleton having this SOAP request here. So what is skeleton here? Skeleton is a predefined class. Here is, if this is service class is a Java, skeleton is a Java class here. If it is C#, skeleton is a C# class here. If it is C++, skeleton is a C++ class here. So now here skeleton is a predefined class. This class depends on this service class here. So in our case, our service class is a Java, so skeleton is a Java here. So skeleton will take this SOAP request here. Skeleton will read this XML file to get name of the method, to get parameter values, and to get the parameter types also here. So now this skeleton having that method client requested method details here. So what this skeleton will do? Skeleton will invoke the client requested method on this actual service class by passing this 10,10, and it can understand that client has requested add method to invoke int here. So that skeleton will invoke the same method, add method int value by passing this parameter values here. Now skeleton will get this return value as a 20 here. Now this 20 needs to send to this client location here. How skeleton will send this return value to the skeleton here? Again skeleton will prepare one XML document. That XML document is called as a SOAP response here. In this SOAP response, it will store this service return value here. Why skeleton is preparing this SOAP response here? Here SOAP response is an XML document. This XML document can be understandable by any programming language. Here the client application developed by using C++. Even C++ is also can understand the SOAP response, can understand the XML, can read the data from the XML document. So that's why skeleton is storing that return value into the XML document here. Then why we can call it a SOAP response here. Again skeleton will use some set of predefined tags from this SOAP to prepare this SOAP response here. So now here this SOAP response contains the SOAP tags. So that's the reason we can call it a SOAP response here. Now here the SOAP response is available at the service side. So somebody will move this SOAP response from server location to the client location here. So who will do that job here is again HTTP protocol will do that here. Why HTTP protocol will do that? Here HTTP, as we know that HTTP protocol is a transportation protocol. It will move something from one location to the another location here. So in our web services, HTTP protocol will move SOAP request from client location to the server location, and it will move the SOAP response from server location to the client location here. So now the SOAP response is available at the client location here. client location here, which contains the return value as the 20 here. So now this value will read by this SOAP response will read by this stub. Stub will get that return value. That return value will hand over to this client here. Will hand over to this client here. So this is the way communication will be happen in between the client and the server here. So observe here, the client application is developed by using different language here, and this application is developed by using the different language here. Meaning what? This is developed by using Java, this is developed by using C++ here. But still we are able to communicate these two applications by using the web services here. So I told you web service is a specification here. They are suggested these rules to share information between the two applications here. So as we discussed, web service has suggested 6 components to share information between the two applications here. What are the 6 components here is? One is stub, one is skeleton, next one is the WSDL, UDDI registry, SOAP request and SOAP response here. So if web services has not provided these 6 components, maybe we cannot share information between these two applications here. So now here we will discuss again who will provide this skeleton here, what is the skeleton here, and what is this WSDL file we will discuss here, and what is this UDI registry, and what is this stub, and what is this HTTP protocol here. So I will remind you all the steps here is, here WSDL is an XML file here. WSDL is an XML file here is, which contains service class details, which contains the service class details. Who will prepare this service class, who will prepare this WSDL file? No, service provider will prepare this WSDL file here. So to prepare this WSDL file, we need one tool called WSDL generation tool. We need one tool called what? WSDL generation tool here. WSDL generation tool here. So service provider, after developing this service class, he will use one WSDL generation tool. Using WSDL generation tool, he will prepare the WSDL file here. So now here, what is the input? What is the input for this WSDL generation tool to generate the WSDL file is? One is service class. One is service class is the one input here, and the next one is we need to pass the endpoint URL here. So if we pass endpoint URL and if we pass service class as a inputs to this WSDL generation tool will generate this WSDL file here. So after this preparing this WSDL file, we need to hand over this WSDL file to the client. So now here, how you will hand over this WSDL file to the client? We need to store that WSDL file into the UDI registry with some unique name here. That unique name we will send to the client here. Using that unique name, client will get this WSDL file here. Now I will tell you why we need to prepare the WSDL file. Why we need to prepare the WSDL file? WSDL file is used by the client to know about your service here. So that's the reason we are preparing the WSDL file here. So the role of WSDL file in the web service architecture is to understand service details by the client. So that's the reason we are preparing this WSDL file here. If already client knows about your service class, maybe WSDL file is not required here. The purpose of WSDL file is client needs to know about our service class. So that's the reason we are preparing the WSDL file. That WSDL file we are shared to the client here. Now one question we need to understand here is, sir, do we need UDDI registry to share this WSDL file to the client? I can say that it's not a mandate. It's not a mandate here. So then how service provider will share the WSDL file to the client? So he will send the email to the client. So by email attachment here. So if service provider sharing this WSDL file through email attachment, now WSDL UDI registry is not a mandate here. So as we discussed beginning of this video, web service has given 6 components here. UDI registry is not a mandate here, it's a option here. Why it is option here is, service provider can share this WSDL file to the client through an email attachment also here. Fine. So anyway, client got this WSDL file. Maybe he downloaded from the email attachment, or maybe he got from this UDI registry here. So after that, he will prepare the stubs. To prepare the stubs, client will use the stub generation tool here. As we discussed here is, if this client application is C++ application, stub should be the C++ here. Stub should be the C++ here. So stub is a generated class. We have another name for the stub is proxies here. If it is Java, stub is a Java here. Stub is a Java here. If it is C#, stub is a C# here. So in our case, it's a C++ client. So that definitely it is a C++ only here. So now here, whatever methods we have in the service class, the same methods will be available in the stub here. But don't expect the same method implementation here. We have different implementations here. Here we have the different two implementations here. So after generating this stub, client will create the stub object here. With the stub object, he will invoke the add method by passing the parameter values here. Then now stub receives the method call from the client application here. It will store that details into the XML format here. This XML contains the name of the method, parameter values and parameter types also here. So this XML document is also called as a SOAP request here. Why we can say that it's a SOAP request here? Because stub uses some predefined tags from the SOAP. So that's the reason we can say that it's a SOAP request here. So make sure that SOAP request contains the name of the method, parameter values and parameter data types here. So now here this XML document needs to move from client location to the server location here. Who will do that job? No, HTTP protocol will do that job here. So the responsibilities of the HTTP protocol in the web service architecture is, it is moving SOAP request from client location to the server location here. This SOAP request will hand over to the server. Server will hand over the SOAP request to the skeleton here. Skeleton will get this client requested method details from the SOAP request. Means it will get the name of the method, parameter values, parameter types also here. Now skeleton can understand that yes, client requested add a method of type int comma int by passing this values here. Now skeleton will invoke that actual method call on the service class. It will get this return value as a 20 here. Now this 20 needs to send to the client here is how skeleton will send that 20 value to the skeleton is client here is skeleton will prepare one XML document. That XML document is called as SOAP response. In the SOAP response, it will store this 20 value here. So why we can say that it's a SOAP response here? Because skeleton will use again some set of predefined tags from the SOAP. So that's the reason we can say that it's a SOAP response here. So now we have SOAP response with the return value. Now this SOAP response will move from service to the client location here. Who will do that job? Again, HTTP protocol will do that job here. So now we have this SOAP request at the client location here. So this SOAP request will hand over to this stub. Stub will get the return value from this SOAP response, and this return value will hand over to this client here. So now the purpose of this SOAP is a protocol. It contains a set of tags. These tags used by the stub to prepare the SOAP request, and these tags used by the skeleton to prepare the SOAP response here. So we can say that SOAP is a messaging protocol here. Yes, we are preparing messages here at the client side and the service side. So that's why we can say that it's a messaging protocol here. So here HTTP protocol is a transportation protocol here. Why we can say that it's a transportation protocol here? Because it is moving SOAP request from client location to the server location, server location to the client location here. Meaning what? So HTTP protocol is moving the SOAP request from client location to the server location. It will move the SOAP response from server location to the client location here. So that's the reason we can say that it's a HTTP protocol. HTTP protocol is a transportation protocol here. So now here coming to the skeleton here. Skeleton is a predefined class. Skeleton is a predefined class. And what is the responsibilities of the skeleton here is, skeleton will get the method details from the SOAP request, and it will invoke that client requested method on the actual service class. It will get the return value. That return value will store into this SOAP response here. So I can say that skeleton will read the method details from the SOAP request. It will invoke the same method on this actual service class. Again, that it will receives the return value. That return value will be stored into this SOAP response here. So the responsibilities of the skeleton is it will read the SOAP request to get the name of the method, to parameter values, parameter types. It will invokes the actual method call on the service class. It will get the return value and it will prepare the SOAP response by storing this return value here. So this is the responsibilities of the skeleton here. What is the responsibilities of the stub here is stub will receive the method call from the client. It will store the method details into the SOAP request and it will receive the return value from the SOAP response. That SOAP response will be read by the stub here. It will get the return value from the SOAP response and that return value will hand over to this client application here. So this is the way communication will be happen in between the two different applications. We can say that two interoperable applications here. Why we can say that two interoperable applications here? Because this application can be developed by using any language, it can be run on any operating system, it can be run on any system configuration here. And here this can be developed by using any language, it can be run on any operating system, it can be run on any system configurations here. Now these two applications are called as a interoperable applications here. But still we are make communication between the two interoperable applications using the web services here. And at the last we want to discuss, sir, you are saying that skeleton is a predefined class. Who will provide this predefined class here? And here visitor generation tool is a one class here. Visitor generation tool is a one class here. At the client side is also stub generation tool is also one predefined class here. So assuming, sir, assuming here I want to develop this web services. I want to develop this web services here. So to develop the web services, mainly you need two components here. One is visitor generation tool you need, and you need the skeleton class here. So if you have these two classes, you can develop the web services here. So who will provide this visitor generation tool and this skeleton here? So assuming here, if you develop this application using Java, so Sun should provide this visitor generation tool and this skeleton here. No, I want to develop this application using some C# here. So Microsoft should provide this visitor generation tool and this skeleton here. So meaning what? If you want to develop this web service using Java language, we require some API. That API should be provided by the Sun microsystem here. Same way, if you want to develop this service application using C#, so C# should provide some API to develop the web services here. No, I'm a client. I want to develop this client application. So now here, if you want to invoke some methods from the web services, what is the prerequisite? What is the need? What is the client needs here? Is client needs this stub generation tool here. If client having this stub generation tool, he can generate the stub and he can create the stub object and he can invoke this methods here. So who will provide this stub here? Assuming here I am developing this application using Java, so Sun should provide this stub generation tool here. No, I am developing this client application using C#, so Microsoft should provide this stub generation tool here. No, I want to develop this application using C++, C++ should provide this stub generation tool here. So meaning what? If you develop the web services or client, we required some APIs. Here. If you develop this application using Java, we required some APIs from the Sun microsystem. Same way, if we develop this client using Java again, so Sun should provide some APIs here. That APIs are called as a Java Web Service APIs here. So here we are not Java, we are not C# developers, here we are not C++ developers, we are Java developers. So that we should learn about what are the Java Web Service APIs has given by the Sun microsystem to develop the web service as well as the web service client here. So Sun has provided four Java Web Service APIs here. One is JAX RPC, Java API for remote procedure call, and the next one is the JAX-M, Java API for XML messaging here, and the next one is the JAX-WS, Java API for web services here, and the last one is the JAXO RS here. JAXO RS here. So these APIs should contain this visual generation tool, should contain this skeleton. Same way they should contain this stub generation tools also here. So now here, why Sun has given 4 APIs, 1 API is enough to develop the web service or web service client here. And now we will discuss about using these APIs, we can develop both client application, web service client and web service by using Java language here. No sir, I want to develop this web services using C#. So Microsoft should provide some APIs to develop this web services. That APIs we will use here. Same way, I want to develop this client application using C#. So Microsoft should provide some APIs to develop the web service client here. So we are Java developers, so we should learn about only Java web service APIs. Using these APIs, how to develop the web service and how to develop the web service client, we will discuss here. In the next video, we will discuss what are this JAX RPC, what is the JAX-M, what is the JAX-WS, and what is the JAX-RS, and what are the difference between these APIs also we will discuss here.